Thank you, everyone, for coming out today. Just looking back on this past year, we were in India, just Johnny and I, a little short of a year ago, and we were the team that was covering Asia Pacific. We've seen amazing take-up of ClickHouse across India. It's great to see so many familiar faces today. We have hired out a team to help support this growth in India, and we will continue to invest in India. So please, Rakesh and Anshul have recently joined in the past few weeks, so please do say hello to them today when we get a little time for Q&A. And then we've also extended the team. So Kunal, Amog, and Kevin, who are over here in the corner, are part of the PeerDB team, and they'll be talking a little bit more about Postgres CDC. Please do say hello to them as well. And then Piyush, our support engineer manager. So Piyush has actually built out global support orgs for VMware and Atlassian. He's going to be doing the same for ClickHouse. As a matter of fact, if any of you are interested in any jobs at ClickHouse, we are going to be hiring in our support org based out of Bangalore here. So have a chat with Piyush. And then Pratik and Chaya have recently joined. They're two of the support engineers here as well. They were checking everyone in. So again, any questions, please do ask the folks with the ClickHouse shirts. It's been an amazing week, so there's a lot of familiar faces that we see in the crowd here. Thank you for all joining us here. We're going to continue to contribute to the community. You'll see a lot more online training, live instructor-led training. Like for instance, we're running one on query optimization this upcoming Wednesday, but we will do live instructor-led training every quarter, at least every quarter. So please do join us there to learn a little bit more. We have a new certification program as well, which we just released a couple months back. And we look forward to coming back and doing more of these meetups. We'll probably be back around Current or Kafka Summit here in the next few months, potentially another meetup. So thank you all for joining us today. We do have a packed agenda. So Johnny and Rakesh, from our side, we'll share a little bit more, and then we'll hear from the PeerDB guys around Postgres CDC, and then a huge thank you to Platformatory, Last9, and Signos for sharing their talks around ClickHouse as well today. So thank you everyone for joining. I will hand it over to Rakesh.
If you see, the journey has been fantastic, right? So the product has been started in 2009. So one of our co-founder, Alexei, so he developed this product back in the days, 2009. And the reason behind that was there was no database back in the days to support a big scale of clickstream handling the big data warehouses, right? So if you see the name ClickHouse, it emerged from the technical word, it's clickstream data warehouse. So back in the days, Postgres, Oracle, SQL Server kind of a databases was not able to handle analytical OLAP data warehouse metrics with the large volume of data. That is when it has been started. And if you see the global growth and adoption, so from in 2016 we got released in Apache as an open source, and 2021 is where the company has been incorporated. Our founders, Aaron, Alexei, and few of our founders based out of our headquarters, based out of Netherlands. So this is where the company is actually incorporated in US, right? So if you see, starting from 21 to 25, there is a huge rapid growth and evolution. And from 29 to 2016, it is more of a append-only kind of a database. And if you see, starting from 21 to 25, now we are going towards a database, a single real-time database which can handle multi-model data types. Meaning we have a JSON support now. We can easily offload the data from Mongo and get 100x performance. We have a full text search inverted Lucene-based index coming in a couple of months, which can offload very search-oriented workloads from open search kind of a databases to get the better analytics, right? And if you see, the main top priorities for 2025 in the organization is the join optimisations. So that is where we were having a little bit of a struggle from a couple of years. and we have a huge initiatives, engineering efforts, and investments going on towards that. And a lot of people are asking now to become a mix of both transactional and analyticals. That is where the joins will become much priority for us. And vectors is of course is in the beta stage already. And if you know DeepSeek is using ClickHouse as a backend database storing all their vectors, right? So ClickHouse is powering the entire vector space there. So which is interesting, and you can read a blog there, right? So there's the rapid growth and innovation happening towards across the company. Yeah, just a little bit of numbers here from ClickHouse open source and ClickHouse cloud. If you see this, we have crossed almost 39K stars, very close to Spark. I think we have already crossed Spark, if I'm not wrong, probably. Yeah, if not, probably maybe in a month we'll reach there. So amazing, stats here. 1.3K contributors, and active community members is you can most of you probably have joined our Slack communities and things like that. It's going to go bigger and bigger. Since we have a team here, we are going to have a lot of meetups, a lot of community activities as well. And ClickHouse Cloud, we have slightly outdated slide. So we have now more than 350, 400 plus customers. And we are available in all three major cloud platforms, AWS, Azure, and GCP. Yeah, as I said, slightly outdated. Azure is GA now. So you can deploy ClickHouse Cloud in all three major platforms. And some of our big logos, like Microsoft, even if you look at those couple of banks, right? So so you name the industry, everybody needs analytics, and it comes in all walks of life, right? So that's where the product fitment is. Yeah, so just quick overview of what is ClickHouse. You all know it's open source. Learned about the background. It's there from 2009. 31,000 of GitHub stars, and one of the very well known in the OLAP industry. And I think it's one of the leaders now in the OLAP space, right? So from the technical perspective, the product is column oriented, right? So all of your columns is stored as a files, and it is completely column oriented, highly compressed. We use amazing compression algorithms there, and sorting and indexing, works well behind the scenes. Automatic merge happen. You really don't have to manage most of the things. So managing the parts and putting that to disk is very efficient. That is one of the key concept, and we use vectorized query engine for faster query processing. All the data is encoded. We operate on encoded data, highly processed algorithm for decompressing the data and giving the result back to the client. Highly distributed replication for high availability, sharding, distribute the data to multiple servers. You can have a scatter gather kind of a mechanism as well here. Multi-master, this is a cross region, you can deploy anywhere, there's no restriction. You can deploy from bare metal to VMs to Kubernetes and Docker, you name it. So there's no restrictions. And finally, it's all OLAP, right? So OLAP plus, as I said, we are moving towards a multi-model. So mostly, predominantly, our use cases are analytical use cases. We'll talk about a little bit on use cases, logs, logging and aggregations, powering the dashboards, making the dashboards as a fast boards is one of the another use cases typically our customer use for. And yeah, so it's getting towards, we are getting towards a product where you get all the data types, all the data models in one single platform. So it reduces the complexity of the architecture, bringing all data one platform kind of a theme. Yeah, some of the use cases. Predominantly, we see most of our customer using with logs, events, and traces. And observability is another next area we are seeing a lot of tractions out there. You can see some of the logos, eBay, kind of companies using us for log management, events, and tracings. Real-time analytics and business intelligence goes hand in hand and gets overlapped. Yeah, so everybody wants real-time analytics. Everybody wants the dashboard to becomes most faster, and they don't want any delay. The faster time to insight, faster time, better insights is better for all the customers, right? So that is where we are keen at, and some of the logos you can see, Disney is using us, Cloudflare is using us, and BI tool is predominantly most of our customer users. Now ML and generative AI is another space. Again, is one of the initiatives. You can run all your ML models on top of database, making the reads and writes there. Getting into generative AI space, Vector is another one top priority for us for the financial year 25. The vectors you can store, embeddings in ClickHouse very easily and start, writing your generative AI applications. Use any LLMs and basically it becomes analytical OLAP, a database with contextualization in place. That's where we are heading into from the ML and generative AI perspective. Yeah, there are a lot of features. Lot of features. Just talk about few important one, few key features of ClickHouse. Speak SQL. We use standard SQL. Most of the things which is supported in ANSI SQL 92 compatible dialect is also supported with ClickHouse. We support most of the functions, and hundreds of functions available for JSON and full text search, and vector indexes, skip indexes. So a lot of things with respect to SQL. Very easy to write. There's no need to learn a different technology as such. It's very 95% compatible to ANSI SQL, I would say. Lots of writes built for high throughput. If you are inserting billions of records, millions of records, we use all the resources available in the system and makes the system parallelized. We use MPP technology, massively parallel processing technology, to stream the data into the system. That is where you get that blazing fast, high write throughput there. Distributed, replicated, and sharded. Put the data across different servers. One of our biggest customer is using 4,000 clusters, 4,000 servers in a cluster. So right, think of the volume and think of the data size which they are storing. It's almost very 100, I think 50 to 100 petabytes of compressed data they are storing in the servers. Efficient storage, yeah, one of the important feature, I would say. We typically see 10x compression by default in whichever data type you put, right? So if you optimize a little bit of your data model, you can see up to 20x compression on the data which you put into ClickHouse, which in turn reduces your total cost of ownership. Very fast. We use vectorized query engine execution. So scanning and skipping the granules, skipping the parts is very important. And the engine becomes has to be very performant. And that is where the blazing fast, low latency, high throughput kind of a database comes into picture here. Joins and lookups, as I said, we are having major initiatives there. So we support all types of joins, by the way. So left outer, right outer, inner, subquery, CTE, all are supported. And some of the optimizations are coming in very soon. And Johnny will talk a little bit more on that aspect as well. So to summarize, what is ClickHouse? ClickHouse is a SQL distributed OLAP multi-model built to handle high throughput, low latency, built for speed, scale, agility. If you're looking for high throughput, low latency, yeah, please try ClickHouse. I'll just skip this part. This is very simple syntax, how you create the table. The important part here to notice here, the engine, right? So there are multiple engines. Merge tree is the default engine there. There are other engine for deduplicating the data, replacing merge tree, and aggregating merge tree for aggregating, summing, and and other aspects. There are a lot of integration engines as well. You can directly integrate with the Kafka, Mongo, MySQL, and read the data from the remote databases as well. So very easy, and we also have recently added embedded RocksDB as well. So yeah, so very simple. You can see multi data types here. We support low cardinality, array, maps, tuples, yeah, JSON. So it's coming now. You can also, and probably in the next meetup, we'll put up full text index and how to query and put the data in vectors as well, right? So just a simple, very similar to MySQL kind of a database, but important part here is to look at the engine, what kind of engine we use, right? Some of the SQL basics. It's very important to understand ClickHouse is made or meant to handle large batches. It's very important to know that batching is very, very important when you start writing the data. When you insert the data, you'll always have to batch and insert the data to get the maximize the performance from the ClickHouse, because every inserts will create a part. Part is nothing but a logical folder where all of your data goes and stores in the most smallest granular unit called as granules. That is where your data will be stored and processed and fetched and served back to the request. So either batch yourself in the client, or there's an option of turning on in the engine. It's called as async insert. If you turn on the async insert, engine will take care of batching it. So you start streaming the data, engine will pull the data into the memory and create the parts, and then flush it down to the disk and acknowledge back to the client. So either, I think by default it's now going to be a async insert in coming days. That's important to know. Reading data, there's different ways of reading data. There are multiple views in ClickHouse. The two important is normal view, which is a saved query. You all know it's very similar to all the databases. So the important part I want to touch here is the materialized view, right? In materialized view, we also have a refreshable materialized views, but what's unique about materialized view is its insert trigger. As soon as the data comes into your raw table, it immediately fires the query of your materialized view and updates your destination table, and you can start seeing that within 10 seconds by default. And now we also have a refreshable materialized view where you can schedule your materialized view for probably minute or half an hour or 1 hour, and get the rollups and aggregation stored in the materialized view. So pretty cool from materialized view and a refreshable materialized view standpoint. I think we're also going to talk a little bit more on that as well. Just last slide. There's slight difference of architecture between open source ClickHouse versus ClickHouse Cloud, right? So if you see, ClickHouse architecture is having replicas, multiple sharded cluster, and you manage the coordination using ClickHouse Keeper, etc. Whereas in ClickHouse Cloud, it is 3-tier architecture based. You have the proxy or a load balancer at the top, and then you have a compute in the middle layer, which actually serves the data. And it is one single shard, limitless database, unlimited storage. It's backed by object storage. It could be S3, GCS, or ABS. All your data which is written will go and ideally store in object storage. And based on the query pattern, it will get pre-warmed or pre-fetched into computes and stored in the columnarized, compressed, highly compressed in the encoded format, and get the results from the compute Kubernetes pods. So slightly difference between the architecture, but really interesting, and we are happy to talk more about that. So we are here after the sessions and even the Q&A duration, Q&A sessions. We can always chat about that.
Nice to see you guys again. This is my third time coming to India, so really excited to talk about ClickHouse. I was here a year ago as well, presenting about an intro to ClickHouse, so I'm very excited to talk about some of the initiatives and potentially looking at some of the features and functionalities that have been introduced into ClickHouse over the last year and also the future roadmap as well. So I'll just pivot over to the next slide. So before I get into what has been implemented, I kind of wanted to talk about the roadmap and what's coming in 2025 for ClickHouse. So I'm going to ask my friend Amog over there just to pivot over. And so this is a public page. It's created by Alexei, our founder of ClickHouse. And as you can see, for 2025, the core focus for ClickHouse is, not surprisingly, joins, doing everything around joins, and data lakes. They're kind of the two big themes that we're seeing with ClickHouse. So everything from iceberg support, delta lake support, even more functionality on top of data lakes. So things like being able to run materialized views on data lakes. That's phenomenal. I'll talk about some of the integration with Unity catalog as well for iceberg and some of the features that you can see there. Time travel for iceberg, for example. Having things like pre-where support for Parquet and for iceberg files as well. A lot of these functionality that's been requested for a long time is now being implemented in ClickHouse to be able to use ClickHouse as the SQL query engine to run on top of your data warehouse. So we're kind of seeing this as an offline data store where you can use ClickHouse to run all of your federated queries across your iceberg, your table formats, your open table formats, but also to be able to run your hot queries in ClickHouse in sort of really fast, highly compressed ClickHouse format as well. So yes, the big initiative for us is data lakes. The second one I just want to touch on, if you can scroll up a little bit, is more about the query engine itself. So with ClickHouse this year, the focus is, I think Rakesh did a really good job of talking about the history of ClickHouse and how it came from an append-only data store to run very fast analytics and aggregations across ClickHouse. That required a very flat table structure. So everything had to be parsed, denormalized, sort of table structure. The big focus for this year is to really fix joins. It wasn't really a key focus because ClickHouse the primary focus was for aggregations and for OLAP, but it's being used as a real-time data warehouse, and that requires lots of joins, lots of star schema, lots of very large complex joins. And the PDB guys, obviously, the CDC solution from Postgres, bringing across changes and updates from tools like Postgres, for example, also require a lot of joins. So naturally, this sort of functionality is key to ClickHouse, and it's a key focus that we're investing in this year as well. Some really good optimizations there, and we'll have some benchmarks that I can share later in the slides. If you scroll up a little bit more. So the other parts is really around data storage. And mostly it's around the JSON object. It's a very anticipated feature to be able to work with JSON semi-structured data in a very efficient manner. So that's why ClickHouse has built the JSON data type to be able to insert dynamic data into ClickHouse into a very structured, well-defined format on write. So you're not doing it on read time, you're actually defining the data type on write. And hopefully that JSON object will be GA in the next month or two to be able to work with semi-structured data and store that data correctly into a ClickHouse format as well. Lots of great other features there as well from a data perspective. And of course, the last one I'll touch on is just some stuff on integrations as well. Sorry, it's a bit hard to see. So more support for UDFs, more support for things like PromQL. In, I think, 24.8, we also introduced a time series data engine into ClickHouse to store and handle metrics in a better and efficient manner. So now on top of that is the work on PromQL support to be able to serve that data out and then have a more native sort of language to query that data as well. All right, cool. So that's publicly available and it's always updated. You can see all the PRs and the issues against that, and we can keep track of how those are all progressing. Some really cool features in 2025, very exciting. Okay, all right, cool. So that's what's coming, I guess, in 2025. If we look at what has actually been delivered, quite a few really good features. I've got a little link there which isn't showing up. There's a YouTube channel that Alexei and the team will go on every month, and they talk about all of the releases and updates that they do on YouTube, live on a live YouTube call. So these are from versions 24.8 to 25.1, and just for reference, the versions are kind of the month and the year is how that's referenced, right? So 24.8, 25.1 is how the versions are released, and we're pretty good at getting them out on time. So usually they do come out within the month, and some of those features are quite interesting. So things around, for example, one of my favorites for anyone doing observability is, Rakesh touched on the merge tree engine and how the merge works. Things like the reverse table ordering by default, that's really cool for observability. So now you can sort of create your primary key in descending order, and you can query the latest data very, very fast, rather than sort of querying the bottom of the table. So those sort of improvements are there. Setting custom HTTP headers, streaming of HTTP events as well. Lots of functions for streaming HTTP. That's quite cool coming into ClickHouse. And from a performance improvements perspective, there's no surprise there. Most of them are around joins. Being able to run joins and have lots of performance improvements around joins. Most of that was because of the join optimizer or analyzer that is now by default. There was a lot of rework that was done in the new join optimizer. Also working on a cost-based optimizer, so that's also something that we're working on, but a lot of improvements are definitely around joins and how that works. Some interesting more feature type requests, so obviously Iceberg support and having that integration into things like the Unity catalog or Polaris catalog there as well. So there's a new Iceberg table engine, for example, that will have that integration with the Unity catalog. There's actually a really good blog, I think, on that. It was a release on 24.12 where the founders of Tabular were actually on that release call, and they show that integration with the Databricks Unity catalog there as well. Some quite really good features. JSON, the highly anticipated feature, it came out in 24.10, but there's still lots of improvements in that space as well. And integrations, which we will have the team talk about. Postgres, CDC, and some of the other integrations there as well. So one of the really cool features is, just wanted to touch on refreshable materialized views. As you know, ClickHouse already had materialized views, which were an insert trigger. So every time you inserted data, it would trigger a materialized view in real time. So now we've got, now it's in GA as of 24.10, where refreshable materialized views are now a GA product. Really good product, really cool for running scheduled jobs, batch jobs. They can run on a cron-like approach as well, where you can schedule what time, what minute of the hour to run a refreshable materialized view. I actually don't have a demo, that's just a copy, but thinking about a demo, what I would show is a use case for a refreshable materialized view would be using something like the ClickHouse URL table function. So you can just schedule a query to go and talk to a URL and then write that into another table, which is really cool. We do that with our audit logs actually quite a bit. So if you need to capture order events from ClickHouse Cloud, you can use the table URL function with the refreshable materialized views and capture those audit logs into a ClickHouse table and then visualize that as needed. But yeah, really, really good improvement, highly anticipated. I guess refreshable materialized views are not a new thing, but they do work very well in ClickHouse. The other thing I'll touch on, refreshable materialized views, they work with final, which is cool. So now you can use them with things like replacing merge tree or collapsing merge tree, anything that's running final. You can't do that with the real-time materialized views, obviously. So there's some really good features there. So as I mentioned, joins, lots of improvements in this space. So, parallel hash, there's lots of different join algorithms in ClickHouse already. There's, you can even set it to auto, for example, and it'll try and pick the right sort of join algorithm for the specific join type. Lots of improvements specifically around, and you'll see, I guess, watch this space. If anyone's following the TPCH benchmarks, the 22 queries for joins and star schema, ClickHouse is definitely making some headway into that space as well. Some of these queries, there's 22 queries in TPCH that ClickHouse, some of them couldn't even complete because we just didn't have the functionality. We didn't have the join optimizer, for example. So now that we do, there's been a lot of improvements in that space. And you can see now these two particular queries, just by turning on parallel hash by default and some pre-where filtering, just of sort of structuring that query, you can see the results are pretty phenomenal. And there's a lot of improvement in that space as well. Yeah, so watch this space on joins. I think it's definitely going to change how ClickHouse is being used as a data warehouse. All right, another cool feature. So obviously ClickHouse is a distributed system, it's a distributed database. It's been around for a long time. Thanks, Rakesh, for the intro. So parallel replicas, when we talk about multi-master approach and you want to have read-only copies and you want to segregate and have read-only replicas and split your reads by shards or replicas, in open source, that's a little bit easier to do because you can point your specific applications to specific replicas. With cloud, it's a little bit more challenging. So with cloud, as there's only one replica and there's only one shard, it's very hard to come up with a consistent result for parallel replicas in ClickHouse Cloud. So we've actually done that now. We now have an approach where we can enable parallel replicas in ClickHouse Cloud. It's actually available now. You can turn that on as experimental. The way it works and the way I kind of relate this is if anyone's familiar with Kafka and how consumer groups work in Kafka, there's kind of like a leader that's in the consumer group, which will direct all of the requests to the other group, the other consumers in that group. It's very similar to that. There'll be a blog on this as well, where it will talk about how parallel replicas work in ClickHouse Cloud. So that should be coming out pretty soon. But essentially, what happens is you have a request that will go to one of the replicas in the cloud. It's actually not a replica, it's just a node. There's no other copies, but one of the replicas in ClickHouse Cloud. And then that will kind of become the master for that request and distribute the rest of the processing across the other replicas to complete that processing. So yeah, that's a really highly anticipated feature for big scale data analytics in ClickHouse. Okay, so even more on parallel replicas, you can see, 25.1, 40% more improvements on parallel replicas in ClickHouse Cloud as well. So that's pretty impressive load times. Obviously, we're spending a lot more time on that. Essentially, 25.1 will allow the parallel replica to use even more of the replica's resources to run that query. So there's some internal prioritization that's happening in the node itself to be able to run that even faster. So that's another cool feature. So now if you've got a 10-node cluster, you can use all of those nodes for distributing the query across all of the replicas, which is quite cool. All right, awesome. So this is not really a feature. This is just something I wanted to put out there because it's a bit of an unknown when we talk about ClickHouse and how it uses, how it does group buys, how it does like large order buys, for example. So ClickHouse will take that data and it will put it in memory, and it could be very big if the columns aren't very well defined. It could use a lot of memory. So there was always the option from a while back, since 2015, to adjust a couple of settings. And I think one of the hardest things in ClickHouse, from working here for over a year now, is to know what settings to apply in a particular query. So this was already there. But what you can do now is by adjusting those two settings, you can basically tell the query, don't use the memory of my server, but spill to disk for my query, which is really cool. So it's good for large backfills, for example, if you just need to bring data back in without having to use, from a cloud perspective, it won't use any more resources in the cloud, it will just spill to disk. It may take a little bit slower to run, but it will spill to disk and then you don't have to worry about memory overutilization. So not really a feature, but it's kind of configured by default with specific thresholds in ClickHouse Cloud just to prevent over memory utilization and then being able to use the disk available in the cloud rather than memory. I mean, this kind of leads on to another point. Rakesh talked about the architecture of ClickHouse Cloud. So obviously it's S3 and then separate nodes. At the moment, there's kind of like every node has its own cache on the caching system on ClickHouse Cloud. We are future plans building a distributed cache, which will be, hopefully, I don't know if it's going to be persistent, but I hope it's persistent and I hope it's scalable and configurable. But what this also means is when you spill to disk, you can also spill to very fast cache as well. You're not spilling to slow disk. So that should help speed up query execution time as well. So some cool features coming out when it comes to group wise and large queries. All right, and this is very interesting. One of the other top priorities for ClickHouse core team is basically, well, two things: inverted index for free text search, and also vector similarity index. So currently they're in experimental, still quite heavily used by lots of customers, but big focus to make them GA and fully supported by ClickHouse. So this vector similarity index, this particular one, we've enabled caching for some of the dimensions in those particular vectors. So now you can use, cache is becoming a lot more popular, a lot more usable. So now just by implementing cache, you can speed up the query response time quite a bit by being able to cache some of those dimensions in cache rather than reading from disk. Yeah, so kind of watch this space as well. I think that's going to be very interesting with the new vector search. Okay, so a couple more slides. I put this out there because I guess we've been working on the JSON data type for a while, actually. We had our first go of the JSON type a while back, and then that got torn down, and there was a new JSON type that got created, which is a lot more performant and a lot more efficient. There was also the way it works is basically every time you insert data into ClickHouse, a JSON type of data format, ClickHouse will try and infer the schema and the subcolumns, and it'll try and determine the correct data type. And underneath that, there's a particular function. It's a variant or dynamic type function that will dynamically look at the specific data type, and then it will automatically assign the data type to that particular column. So lots of work has gone into this space, but I could really see ClickHouse becoming kind of like a more useful sort of document store as well, where you can become a very fast sort of document engine for querying JSON type data. All of this data is ingested and inserted, and on write time, it's written in the correct format. So a lot of the heavy lifting is done on write. So when you go to read that JSON type, it's already in the right format and it's already extracted correctly. So this is now moved to, it's moved to beta stage, which means it will go GA in about 2 months, I think. That's hopefully when that goes fully productionized. And also, one of the great things you can do now is you can use a specific subcolumn as a primary key in the JSON type, which is awesome. So it automatically knows that there's a date.time and it wants to use that as the primary key because that's already been extracted on the write as well. So yeah, quite cool there. Yeah, really simple. I mean, can we just go back just real quick? So let me just quickly explain. Now, before the JSON type, what would normally happen is that data would have been a string. And then you would have to use a materialized view to go and manually extract every single column of that data type into its own subcolumn. So now you don't have to do that. Now you can just say it's JSON and ClickHouse will do all the work for you on write, which is pretty cool. Okay, also, so from a Python, running ClickHouse in a Python runtime as well, heavily investing in CHDB. If anyone's familiar and wants to play around with ClickHouse and learn about how to run ClickHouse in their own Python binary, for example. So lots of improvements in terms of performance using CHDB. So version 3.0 just came out in correlation with 25.1, I think it was. So yeah, quite a few improvements there as well. Okay, I think this is my last slide, and the only one I'll talk about ClickHouse Cloud specifically. Because of the object store and the separation of storage and compute, what this really enables is the ability to have multiple compute units accessing the same data storage. So now we can have separate services, and normally you would want to do that to separate workloads. So it could be your reads from your writes, for example, or you could have multiple write instances or multiple read instances. But now you can have these different clusters that are different endpoints that are completely independent from each other. And they can all scale up or scale down or scale out completely independent. So you can start from one replica and go all the way up to hundreds of replicas, all independent of each other, but they all access the same object store underneath. There's no rebalancing, there's no managing of replicas or shards or anything like that. It's just all accessing one shard, one replica, which all lives in the object store. So that has gone GA. And there will be more improvements in this space. So one of them will be the distributed cache, which I'm very excited for. And when that comes out, that'll be great because it means the cache will be shared and persistent across all of the different compute nodes. So that's something else that we're working on with a couple of other features and functionality coming up. Thank you very much. Thank you.